In our previous segment, we discussed what is work and then what is heat, and then we found out that when you do work on a system or when you add heat to a system, what it does is it changes the energy of the system. So if you are doing work on the system and you're adding heat to the system, then the energy of the system is going to go up. If work is coming out, or if heat is coming out, if it does work, or if heat's coming out, then the energy of the system can decrease. And we found out that when you add the two together, then that changes the energy of the system. So the question is, well, what do we do if the system is isolated? So if you got this system here that has a certain energy E, and you don't do any work on the system, so that would mean that this is zero. And if you don't add any heat to the system, or don't let any heat come out of the system, then this would be zero. So you'd have 0 plus 0 equals the change in energy. Well, the change in energy is energy final minus energy initial. So that would mean that you take this over to the other side, and it would say that the initial energy of the system has to equal the final energy of the system. That's going to be called conservation of energy. So all three of those statements, energy is conserved. You can't create or destroy energy, or you can't get something for nothing. So all three of those statements are the same, and it means that whatever energy you start with, that's the energy you have to end with. So that's called the first law of thermodynamics. So here is a question. Why do perpetual motion machines disobey the first law of thermodynamics? So assume that you got this perpetual motion machine. So this means it's a machine that once you get it doing something, it just keeps doing it forever and ever, and you don't need to add any energy to the system. So they are always saying that they're creating these perpetual motion machines, and they always involves magnets. But let's assume that we've got this perpetual motion machine. It just runs forever and ever. Why does that disobey the first law of thermodynamics? So a machine is something that you can get something out of. Remember, we talked about levers as a simple machine, and so if you push down on one side of the lever, the other side of the lever goes up. So the purpose of a machine is to get something out of it. You put in a certain amount of force and it gives off a certain amount of force. So assume a perpetual motion machine requires a certain amount of energy to make it run. But some of this energy would be taken out when the machine does something. So when the machine increases your force, then that required a certain amount of energy to do it. And now that means that the energy of the system is a little bit less than what it was before. It was the original energy necessary to make the machine run, but we just took out some energy to do something with it. So now that means there's not enough energy left over to make the machine run. And so there's no such thing as a perpetual motion machine. It disobeys the first law of thermodynamics. Okay, let's look at the second law of thermodynamics. Actually, let's take a break. When we come back, we'll talk about the second law of thermodynamics.